Good morning. Welcome to TMMS Productions, your channel for learning mathematics, physics, and chemistry the easy way. In this video, we will be learning how to solve more difficult questions on congruency in triangles. Let us look at some of the questions that come in the examination. Let us look at question number 1. In the diagram, DF is equal to GF, DE is equal to GE. Angle DEG, this is 60 degrees. And angle GEF, this one is 2x plus 4 degrees. Angle DFE, this one is y plus 25 degrees. And angle GFE, this one is 70 degrees. And you have to find x and y. Do you like this question? Well, let us see how to solve this question. Even before we begin to solve this, we must have the tests for congruency written for us. I'm writing them here: SSS, SAS, ASA, or it will be AAS, and the last one is RHS. Now you have to see which one of these is going to be applicable here. Now as you can see, there are two triangles, DEF and GEF. And in these triangles, you will see that DF and GF are equal. So I marked them with the single line here. And DE and GE are equal. So I marked them with double line here. And you can see the third side, that is EF, is common to both the triangles. So the two triangles are congruent because of SSS test for congruency. So we write just that. So we have written these steps just as I said them. I have written exactly the same way. And now when we write the correspondence over here, see, D is corresponding to G. Can you see? D is first here, GE is first there, then comes E. Now E, that is this angle and this angle, they are equal for the two triangles. So I have put E, and this angle F over here, this one, and this angle F for the second triangle, they are equal. So when we write triangle DEF congruent to triangle GEF, and we must write it in correspondence. And what is the reason? From statement 1, 2, 3. And can you see, this is your side, this is also your side, and this is also your side. So we have used SSS test for congruency. Now that we've understood this, we will have this angle D will be equal to this angle G. Then we'll have this angle over here, this one, and this angle over here. These ones are going to be equal. And then we'll have this one over here. I'm shading this and shading this over here. These two angles also will be equal because they are the corresponding parts of congruent triangles. So we are going to write now statement number 5. Statement number 5, we have to write DEF angle is equal to GEF angle, and we know that GEF is 2x plus 4. So we will write 2x plus 4 degrees. And here we will write from statement 4, and we will say CPCTC. What does this mean? Corresponding parts of congruent triangles are congruent. And also we will write given. Why we will write this given? Because this is given, angle GEF. Can you see that? GEF. Now, what else has been given? Angle DEG. See this? DEG. That full thing is 60 degrees. That means each one of these is 30 degrees. So how do we write that? We write equal to. Now each one of them is half of, because they are equal parts, they are half of the big angle. So we write half angle DEG. That is equal to half into 60 degrees, and that is equal to 30 degrees. And so you will see, therefore we will have 2x plus 4 equal to 30 degrees. That will give us 2x equal to 30 degrees minus 4, that is 26 degrees, and that will give us x equal to 26 upon 2, which is 13 degrees. So we have x equal to 13 degrees. Now we have to come to y. Now in order to see what is y, you will have to look at these two angles. Can you see this is given as y plus 25 and this is given as 70? And aren't these two angles equal to each other? So that becomes our statement number 6. In our statement number 6, we will write angle DFE is equal to angle GFE. Therefore, y plus 25 degrees is equal to 70 degrees. And therefore, we will have y equal to 70 degrees minus 25 degrees. And that will be equal to 45 degrees. And so we have x equal to 13 degrees, y equal to 45 degrees. And that is how we get our answer. Now, let us look at the diagram once again. Can you see that this is one side that was given as equal? This is the second side that was given as equal, and the third side was the common side. So we used SSS test and we wrote the statements like so, and then we saw the corresponding angles were equal because the measures were given in terms of x and y. We managed to get the answers the way we have got it. Now, what I have is a little bit of homework for you. Let us see how many of you have understood this. So, pause the video, or you can take a screenshot of this and then you solve this on your own and post me the value of x and y. Can you see I have changed the values over here? Let us see if you've understood this. Okay, you can write it in the comment box, or you can write it on Facebook, the TMMS Productions, the group is there. Over there you can write, or you can post it on Facebook and tag me in it, and you can put it on Instagram also, no problem. Let me see how many of you have understood this. All right? Okay, now let us come to another question. Do you like this question? Question number 3. There is a circle. The figure shows a circle with center O, in which OM is perpendicular to chord PQ. So we have OM, which is the center, and from here OM is drawn perpendicular, so like so. And we have to prove that PM, that is this, is equal to MQ, that is this. Now what do you see? You see the right angle. What else do you see over here? You see the circle. Now circle has to have the radius, so we will have to show the radius. So we will draw this as the construction. So OP becomes the radius. Now this side also, because see, basically what you have to look at, you have to look at what they are asking you to prove. They are telling you to prove PM is equal to MQ. Now PM and MQ, they are part of which two triangles? If I draw this dotted line, I draw the construction over here, then you will see that gives me one triangle. And MQ is part of another triangle like this. Can you see that? Now, isn't OP and OQ equal to the radius and radius? So, aren't they equal? So, we have these are equal. And then we come to this common side, which is OM for this triangle and this triangle. Can you see that? Now, you have to see which one of the tests we are using. Is it SSS? No. Is it SAS? No. Is it ASA? Are there two angles? No. Are there two sides? Yes, there are two sides. But remember, we have OP and OQ are equal and OM. Now, it becomes ASS or it becomes SSA. Now, that is not the test. The very fact that this is 90 degrees because OM is perpendicular to PQ, we can make use of the right angle triangle and we can make use of RHS. Let us see how we apply this. Right angle is there. OP becomes the side opposite right angle. OQ becomes the side opposite this right angle. And so you see that right angle, then we have the hypotenuse which is equal, and the third side is OM. So you see it is RHS, test for congruency. So we'll write just that. So we have written all the statements the way I told you. First one will be the 90 degrees, that becomes your R. OP and OQ are the sides opposite 90 degrees, so they become hypotenuse, so that is RH. And OM is equal to OM, that is the common side, and that is your S. So did you understand how we got it as RHS test? That is what we have written here. Now, the fifth statement will be, we look at PM and MQ. Now look at this PM. PM is opposite this angle and MQ is opposite this angle. And this angle and this angle, they are congruent because they are the congruent angles of the two congruent triangles. Opposite this is PM and opposite this is QM. So we will write therefore PM equal to QM, and that will be because of statement 4, and we will say corresponding parts of congruent triangles are congruent, and that is what they had asked us to prove, and so we proved it. And so that was our answer. See the way we have to present this? Are we getting it? Now let us have the last question to be solved. Do you like it? In the diagram, PQ is parallel to CD with one arrow and one arrow, and PR is parallel to AB with two arrows and two arrows. And we also know that QD, where is our QD? Here. And BR is here. Now QD and BR are equal, and we have to prove that AQ, that is this one, is equal to CD, that is this one. And also we have to prove that RC is equal to BA, that is this one. Now, which are the two triangles that you see which contain these two sides? Of course, it will be AQB and CDR. But we know that in the two triangles, we have to prove that the two corresponding sides are equal. So, you have to connect what is given as equal, that is QD, and what is equal here to it, BR. So you got to connect QD with BR. Now, because we know that these two are equal, how will I connect with QB this DR? What is QB? Isn't it QD plus DB? And what is DR? Isn't it DB plus BR? So you will see if this was X units, so this also would be X units. And if this was Y units, this length from here to here would have been X plus Y. And this DR also would be X plus Y. So you see QB and DR, they are equal. But now that gives us only one side. Now, which is the test for congruency with only one side? We have either AAS or ASA. Both of them are same, two angles and one side. So now, which are the angles that are equal in these two triangles? Let us mark this triangle like this. So I'll mark this triangle, shade it a little bit, and this one I'll keep as blank. This will be white triangle. I'll call this as blue triangle. All right? Okay. Now, can we see these parallel lines? And these parallel lines are here, and this is the transversal. So what kind of angles are these? Aren't they corresponding angles? And so we have this angle equal. Now let us look at the other parallel pair of lines. Can you see these two? That is PR and AB. Aren't they parallel to each other? And so we will have this one, I'm marking with one ring. This angle and this angle, they are going to be corresponding angles as well. And so we are going to get ASA. Now let us see how we write the statements. Now when we write the statements, always write what is given. Now can you see that QD and BR are equal? So we write QD equal to BR and we write the reason as given. But we are not interested in QD and BR, we are interested in QB and DR. And how do we get QB and DR? By adding this DB to each side. So we add DB and DB to this statement. Can you see that? And we write over here from statement 1 and adding DB to each side. And then we say QD and DB is QB. So we write QB. DB plus BR gives us DR. So we write DR. And now we are writing the two triangles. Which are two triangles? AQB. So we say in triangle AQB and a triangle CDR. That is like so. we are going to start in order. Remember, the correspondence is important. The order in which we are writing is important. We have two angles which are equal and one side. And remember, it is not AAS, it is ASA. Although both of them have the two angles and one side, you have to write in order: angle, then side, and then angle. Okay, so we are writing this angle, which is angle AQB. So angle AQB equal to this angle, which is angle CDR. And what are they? They are corresponding angles, since AQ is parallel to CD and QR is the transversal. Now, next comes the side, QB and DR. So we write this exactly the same as this. We write statement 2. And the third angle is this, angle ABQ equal to angle CRD. Can you see we've written just that? And what type of angles they are? Corresponding angles. Why they are corresponding? Because PR and AB, they are parallel, and QR is the transversal. And because of that, these two triangles, I'll write that AQB, triangle AQB is congruent to triangle CDR, and that will be because of statement 345 and ASA test for congruency. Now that we got the congruent triangle, remember, what are they asking us? They are asking us AQ and CD. AQ and CD, they are equal. Now, haven't we marked them with that blue? Why did we mark them with blue? Because that is what they asked us to find. Now, you got to check it out if they are corresponding sides. What does it mean by corresponding sides? They are going to be opposite equal angles. Now, can you see this angle and this angle? They are equal angles. Opposite them will be the equal sides. So, the sides opposite congruent angles are going to be congruent. So, AQ and CD, they are going to be equal. So, we have written just that. Can you see that? AQ and CD, they are equal because of statement 6, CPCTC. What does CPCTC mean? Corresponding parts of congruent triangles are congruent, and that is our answer number 1. What is our second part? RC equal to BA. Now RC and BA. Now RC is part of this triangle and BA is part of this triangle, but both of them are opposite the shaded angles. Now these shaded angles over here, they are congruent already, they are equal. So opposite equal angles will be the corresponding sides. So this will have AB opposite to it. This angle which is equal to this will have CR also will be the corresponding sides. So AB and CR are going to be corresponding sides. They will be equal. So we write AB equal to CR, and that will again be from statement number 6, which said that the two triangles are congruent, and we write CPCTC, which means corresponding parts of congruent triangles are congruent, and that is our answer 2. So as we come to the end of the video, once again I'm telling you that this is your homework. Record the diagram, record the values quickly, put it on pause, and give me the answer for X and Y, and you can put it in the comments. I will see to your comments, or you can post it on Facebook, tag me in it, or you can put it in your Instagram story, tag me in it, and let us see how many of you get correct answers, okay? So I hope you're enjoying the video as much as I enjoyed making it. Thank you for watching. For more information on the concepts of maths, physics, and chemistry, subscribe to my channel and click on the notification bell so you will be updated whenever I upload a new video. and enjoy learning the easy way.